It is stewing in its own chemical juices. Right now, today, a mountain in Washington state is quietly digesting itself from the inside out. Hot, acidic gases are turning its solid rock core into weak, unstable clay. And if it fails, a wall of liquid concrete carrying boulders the size of houses will scour the valleys below at over 50 miles per hour, erasing everything. They call it a LAHAR. It is not lava. It is not a flood. It is a slurry of rock, mud, and melted glacial ice, so dense it sets like cement the moment it stops moving. And it is aimed directly at 150,000 Americans. What does it feel like to live your life on top of ancient mud, knowing a new batch could arrive with less than an hour's warning? We want to hear your thoughts in the comments below. Stories like this are disappearing under the noise of the daily news cycle. A huge number of people who value this information watch our documentaries and then forget to subscribe. If you believe being a well-informed citizen is a responsibility, take 1 second and hit the subscribe button. You need to know this. Let's begin. The threat from Mount Rainier is not a secret. The United States Geological Survey, the federal agency tasked with monitoring these forces, ranks it as one of the most dangerous volcanoes in the country. But the danger isn't what you think. It's not the Hollywood explosion, the ash cloud, the pyroclastic flow. It is silence. It is gravity. And it is the 1 cubic mile of ice and snow locked on its summit, more frozen water than all the other Cascade volcanoes combined. This is the fuel for the catastrophe. Volcanic heat is only one trigger. An earthquake, a tremor, even just the simple, unforgiving pull of gravity on a mountain that has become structurally rotten could be enough. USGS hydrologist Carolyn Dreger has spent a career explaining this terrifyingly simple equation. Hot rock meets cold ice, and it creates a torrent of water that rips loose rock from the mountain's weak and altered flanks. The mountain is literally falling apart. For thousands of years, an active hydrothermal system has been venting volcanic gases, rich in sulfuric acid, directly into the mountain's core. Think of it like a massive, slow-motion chemical burn. Solid, stable andesite rock is being cooked into a soft, slippery clay called smectite. USGS scientist emeritus Kevin Scott, who spent decades mapping the debris fields of past events, famously warned that because of this internal decay, the mountain is uniquely susceptible to collapse. A collapse without warning. In the valley stretching west of the mountain, life proceeds with a surreal sense of normalcy. In towns like Sumner, Puyallup, and Fife, subdivisions and shopping centers are built on land that looks flat, fertile, and safe. It is none of those things. That flat land is the deposit of a previous LAHAR. And another one before that. The ground beneath their homes is a geologic crime scene, a layer cake of past disasters. Over 300,000 people live in the extended hazard zone, but for more than 150,000 of them in the Puyallup River Valley, the risk is not abstract. It is a number, a timeline measured in minutes. The city of Orting, Washington, sits at the confluence of the Puyallup and Carbon rivers, roughly 30 miles from Rainier's peak. Its 9,000 residents live directly on top of multiple overlapping layers of ancient LAHAR deposits. Former Orting Fire Chief Scott Fielding began championing LAHAR preparedness in the 1990s, bluntly designating his town as Ground Zero. He knew the math. A large-scale LAHAR, triggered by a collapse on the west flank of the mountain, would reach Orting in 40 to 45 minutes. Not hours, minutes. There is no time to pack, no time to decide what to save. The roads will become an impassable gridlock of panic. The only way out is up, on foot. The town's 3 public schools are all located on a single campus, directly in the LAHAR's designated path. If you had just 40 minutes to get your family to high ground, with only what you can carry, what would it be? It's a question thousands of people have to confront as a real possibility? Let us know your answer in the comments. This isn't a theoretical exercise. It's a practiced reality. Brian Terbush, the Earthquake and Volcano Program Coordinator for Washington's Emergency Management Division, organizes the largest LAHAR evacuation drill on the planet. On March 21st, 2024, over 45,000 students from Orting, Puyallup, Sumner, and other districts in the valley participated. They don't run, they walk. A steady, practiced, disciplined pace out of the valley floor and up nearby hillsides to designated evacuation points. They are trained to ignore the impulse to drive because the models show that driving is a death sentence. They are children practicing how to outrun a river of moving concrete. The title of this video states a LAHAR could bury Tacoma in 30 minutes. That is a common misconception, and the truth is far more complex. The good news is Tacoma has more time, a lot more. A massive flow would take roughly 3 to 5 hours to reach the industrial port on Commencement Bay. The terrifying news is for the communities upstream. For Orting, it's 40 minutes. For Puyallup, about an hour. The speed is highest at the start, when the LAHAR is careening down the steep upper slopes of Rainier at highway speeds, up to 60 miles per hour. As it hits the flatter, gentler grade of the Puyallup River Valley, it slows and spreads out, but it also bulks up, gaining mass by scouring the valley walls and riverbed, scooping up trees, soil, bridges, and buildings. This is what makes a LAHAR so uniquely destructive. It is not a wave of water that passes. It's a depositional event. When it finally stops, the material, a mix of mud, sand, and boulders ranging from pebbles to small houses, settles and dewaters, hardening into a solid mass hundreds of feet thick. It buries the landscape permanently. The Port of Tacoma itself is built upon 70 feet of this exact material delivered by a past catastrophe. The engineers and developers who built these communities weren't ignorant. They were opportunistic. LAHAR deposits create perfectly flat, wide open ground, ideal for construction. They built on the evidence of past destruction, betting it would not happen again on their watch. That bet is looking worse every year. If this story is giving you a new perspective on the ground beneath your feet, take a second to hit the like button, and then share this with your family and friends. These are the conversations that save lives, and they are conversations we need to be having right now. The scariest part of the Mount Rainier threat isn't the eruption you can see coming. It's the one you can't. The geologic record is haunted by a ghost, an event that defines the modern risk more than any other. For decades, geologists had mapped a massive, ancient mudflow deposit in the Puyallup Valley they called the Electron Mudflow. They knew it was big, around 260 million cubic meters of material. They knew it happened relatively recently in geologic time, but they could not find evidence of a corresponding eruption. There was no ash layer, no lava flow, no seismic signature of a major magmatic event. It was a mudflow that seemingly came from nowhere, a spontaneous collapse. This was the no-notice LAHAR scenario that scientists like Kevin Scott had warned was possible because of the mountain's rotten core. The theory was that a simple, localized earthquake, or even just the mountain slumping under its own waterlogged weight, could trigger a catastrophic landslide without any of the typical volcanic precursors. The Electron Mudflow was the proof. But when did it happen? For decades, the answer was a vague, about 500 years ago. Then, in July 2025, a team of researchers published a groundbreaking study in the journal Geology. They used a technique called dendrochronology, or tree ring dating. Deep within the electron deposits, they found ancient Douglas fir trees that had been flash buried and preserved in the mud. By meticulously matching the ring patterns of these dead trees with living, ancient trees in the same region, they could pinpoint the exact year, and even the season the mudflow occurred. The result was chillingly precise. The Electron Mudflow happened in the late summer of 1507. No eruption, no warning, just a massive section of Rainier's hydrothermally altered west flank, letting go and sending a river of death down the valley. The 1507 event rewrote the rulebook. It proved that the citizens of Pierce County might not get weeks or days of warning from a rumbling volcano. They might only get minutes. The entire survival of 150,000 people rests on a network of technology designed to buy them those precious minutes. It is one of the most advanced volcano monitoring systems on Earth, and until recently, it was not fast enough. The original Rainier LAHAR detection system, or RLDS, was installed in 1998. It consisted of a series of acoustic flow monitors, essentially rugged microphones encased in steel pipes and buried along the riverbeds. They were designed to listen for the deep, low-frequency rumble of an approaching lahar, a sound distinct from a normal flood. When the system registered a signal that matched the lahar's acoustic signature for a long enough duration, it would trigger an alarm. It was revolutionary for its time, and it had a fatal flaw. The system pinged a central computer only once every 10 minutes to check for signals. In a scenario where your entire evacuation window is 40 minutes, a 10-minute delay in detection is an eternity. People could lose a quarter of their survival time before the sirens ever made a sound. From 2017 to 2024, the USGS Cascades Volcano Observatory, under the leadership of research seismologist Seth Moran, undertook a massive, multi-million-dollar overhaul of the entire network. The goal was ruthlessly simple: cut the warning time down from 10 minutes to just a few. They succeeded. The new system is a technological marvel of layered redundancy. They installed 25 new broadband seismic stations, instruments so sensitive they can detect the unique ground vibrations of a lahar as it forms high on the mountain, long before it reaches the old acoustic sensors. These stations stream data in real time, 24/7. Then came the infrasound. Arrays of infrasound sensors were added to the network. These devices don't listen for ground vibration. They listen to the air. A lahar charging down a valley generates immense, low-frequency sound waves, infrasound, that are below the range of human hearing, but travel through the atmosphere at the speed of sound. This signal often arrives even before the seismic shaking, providing another layer of ultra-early warning. And finally, they installed the most brutally simple and effective detectors of all: tripwires, physical cables strung across the river canyons. When a wall of debris moving at 50 miles per hour hits one of these cables, it snaps. The break sends an instantaneous electronic signal to the operations center. There is no ambiguity, no interpretation. The signal means the lahar is here, right now. All this data, seismic, infrasound, tripwire, flows into a new, automated processing system at the Pacific Northwest Seismic Network in Seattle. Complex algorithms analyze the incoming streams in real time, looking for the combined signature of a lahar. If the criteria are met, an automated alert is sent directly to Pierce County's Emergency Operations Center in less than 5 minutes. From there, a human makes the final call. Jody Woodcock, the deputy director at Pierce County Emergency Management, or her equivalent on duty, would have the terrible responsibility of activating the sirens. There are 42 of them spread throughout the Puyallup and Nisqually River valleys. They are designed to be heard for miles, and their sound is unforgettable. For years, the county tested the sirens on the first Monday of every month using the full, terrifying wail tone. But it caused what they called alarm fatigue. The public became desensitized, and worse, panicked every time the test occurred. So they made a change, a deeply eerie one. The monthly test is now a gentle, almost polite Westminster chime. The horrifying rising and falling wail is reserved for only one thing: a real event. Blue strobe lights were also added to the sirens for the hearing impaired. If you live in the valley and you hear that wail, it means the system worked. It means the seismometers, the microphones, and the tripwires all did their job. And it means you have to run for your life. The ghost of 1507 is terrifying, but the mountain holds the memory of something far, far worse. An event so colossal it makes the Electron Mudflow look like a minor landslide. Around 5,600 years ago, the entire northeastern face of Mount Rainier collapsed. It was not a small slide. A staggering 1.8 kilometers of the mountain's summit simply gave way. The resulting LAHAR, known today as the Osceola Mudflow, was of a scale that is difficult to comprehend. It contained 3.8 cubic kilometers of material. That is more than 10 times the volume of the 1507 Electron Mudflow. It is enough rock and mud to bury the entire city of Seattle, 15 feet deep. The flow roared down the White River Valley, a superheated slurry of rock, steam, and ancient ice. It was not contained by the valley walls. It spilled over them, spreading out in a vast, fan-shaped sheet of destruction. It buried the land where the modern cities of Enumclaw, Kent, and Auburn now stand. It didn't stop there. The Osceola Mudflow traveled more than 60 miles, all the way to Puget Sound. It poured into Commencement Bay, filling in the existing estuary, and permanently altering the coastline of what would one day become the port of Tacoma. The very ground the modern industrial port is built on is the 5,600-year-old hardened remains of this single, biblical-scale event. Geologists study the Osceola Mudflow not as a historical curiosity, but as a casing study for a credible worst-case scenario. It demonstrates the sheer destructive potential locked inside Rainier. It reminds them that while the Puyallup Valley is the most populated and most likely path for a near-future LAHAR, it is not the only one. The White River, the Carbon River, and the Nisqually River on the south side all carry the scars of their own ancient catastrophic flows. The National LAHAR, a massive prehistoric flow down the Nisqually Valley between 1,200 and 2,200 years ago, shaped the land where communities now sit, largely unaware of the power that carved out their home. The USGS, led by its current scientist in charge, John Major, continues to refine these histories, using them to model the future. They know that a future collapse could be directed down any one of these drainages, depending on which hydrothermally weakened flank of the mountain finally lets go. They plan for the worst case, because the geologic record shows that with Mount Rainier, the worst case has happened before, and it will inevitably happen again. I know this is the second time I'm bringing this up, but it really is important. These are the kinds of stories that get lost in a busy world, but they matter. A shocking number of you who watch these deep dives all the way to the end forget to subscribe. If you find this valuable, please take a second to support our work. It makes a huge difference. So, what is it like to be caught in one of these flows? The popular image is of a person being swept away by a wave of mud. The reality is far more brutal. People caught by a LAHAR do not burn from heat. They do not drown in water. They die from trauma and suffocation. The front of a LAHAR is a chaotic wall of debris. It carries trees, cars, and boulders traveling at immense speeds. The impact is unsurvivable. But for those caught in the main body of the flow, the physics are even more sinister. A LAHAR is a dense, cohesive slurry with the consistency of wet concrete. It is not something you can swim in. It is something that engulfs you. The mud is so thick and heavy that it fills the lungs instantly, causing asphyxiation. The sheer weight of the material crushes the body. It is a force that does not just carry you, it consumes you. The danger does not even end once the LAHAR stops. Even a flow that halts in the Kent Valley, south of Seattle, would present a secondary, long-term crisis. The event would dump a colossal amount of sediment into the river systems. In the months and years that followed, normal river flow would carry this sediment downstream, clogging shipping channels, overwhelming flood control systems, and destroying critical infrastructure far from the initial disaster zone. The Port of Tacoma, a vital economic engine for the entire Pacific Northwest, could be rendered unusable by sediment long after the immediate LAHAR threat has passed. This is the multi-layered nature of the risk: an immediate, high-speed threat to life in the upper valleys, a slower-moving burial threat to the downstream suburbs, and a long-term economic threat to the entire region. It's a problem with no single solution. You can't build a wall high enough to stop a major LAHAR. You can't divert it. You can't out-engineer a force of this magnitude. The only solution is to not be there when it arrives. This truth has created one of the most remarkable and sobering civic preparedness cultures in the United States. In Pierce County, LAHAR evacuation route. Signs are as common as stop signs. They point the way out, always up, to the high ground that a flow cannot reach. The state and local emergency managers have embraced a philosophy of radical transparency. They don't downplay the risk. They illustrate it. They run ads. They distribute pamphlets. They hold community meetings. Brian Terbush of the state's EMD has a simple, powerful message he repeats to residents. You can't change that an earthquake or eruption will happen, but you can change how much it impacts your life. It is a message about agency in the face of an overwhelming natural hazard. It reframes preparedness not as an act of fear, but as an act of control. This culture of readiness is perhaps the most powerful tool they have. The technology of the RLDS is incredible, a testament to human ingenuity. But even the most advanced system can only buy minutes. What happens in those minutes is what determines the outcome. Whether thousands of people live or die will come down to whether they listened, whether they took the drills seriously, whether, when the wail of the sirens finally cuts through the quiet of an ordinary day, they grab their go-bags and walk, not drive, toward the evacuation route sign pointing up the hill. The tripwires are set. The sirens are ready. The children are trained to outrun a monster made of earth and water. Mount Rainier stands on the horizon, a postcard of impossible beauty, 14,410 feet of serene, snow-covered rock. It is a symbol of the Pacific Northwest. Dominant, majestic, and permanent. But it is not permanent. Deep inside, the chemistry of decay continues its silent work. The rock grows weaker. The ice pack waits. The steep flanks hold the tension of gravity, stressed by the thousands of tiny, imperceptible earthquakes that rattle the region every year. The engineering has bought time. The drills have created a path to survival. The science has provided a clear, unambiguous warning.